Hi everyone, we are group 11 and today we are defining research with human subjects and considering ethical challenges in AI research. Group 11 consists of Erica Essig, Katie Painter, Drew Weiss, and Gabriel Dandock. For our presentation, we'll be focusing on several different areas. First, doing an introduction to the topic, then going into specific definitions of both research and human subjects, then moving on to discussing the common rule and private information and how it relates to research studies involving human subjects. Finally, we'll discuss a case study that takes these items and apply them directly to research using AI and the ethical considerations behind that. In human research studies, approval must be granted by an institutional review board, or an IRB, and follow their specific standards to proceed with data collection. IRB regulations require the studies that meet both definitions or qualifications of human subjects and research be reviewed by their board. But what does that really mean, and what requirements are necessary for a study to be considered human subjects research? In this module, we will discuss the definitions of both human subjects and research defined by the common rule and how they apply to specific instances in social and behavior studies. The term research is defined by subsection 102 of the Common Rule as a systematic investigation including research development, testing, and evaluation designed to develop or contribute to generalizable knowledge. For a case to be classified as research, it must be a systematic investigation or where the process of gathering information is structured and defined by a purpose set by the investigator. The researcher will follow the structured guidelines throughout the process of data collection. Research can be qualitative, where the data collected is to help generate a hypothesis or theory, or quantitative, where the data collected is to test and find evidence in support of a hypothesis or theory that the researcher created. Research must additionally have a development of a testing process or evaluation of the data collected. Examples of these can include focus groups, questionnaires, pilot testing, or surveys. Finally, the research data collected is designed to contribute as generalizable knowledge and advanced knowledge of a specific field or population. The intent of the data collection is to be applied back to broader populations that the specific individuals studied are a part of. In the redefinition of the Common Rule, there are exceptions to what classifies as research. In 2018, the Common Rule excluded scholarly and journalistic activities, such as literary criticism and journalism, surveillance for public health purposes, data collection conducted by criminal justice agencies authorized by a court order or law, and any authorized activity defined for national security or defense. These types of data collection are not considered research because of their intent, and they were not designed to contribute to generalizable knowledge. For example, journalism in authorized national security surveillance is meant to report, investigate, and inform about specific events or individuals. This information collected does not apply back to general knowledge and advanced literature and is not testing or generating a hypothesis. An example of research defined by the Common Rule would be an anonymous survey sent out to college students on a local campus about their mental health experiences, symptoms, and coping strategies to understand the impact college has on students. The process is structured and generates theories and connections, utilizes a structured survey, and its use is intended to generate new knowledge that can be applied to college campuses and student populations overall. By having these components, this will qualify as research according to the Common Rule.
The term human subjects, as defined by 45 CFR 46, Section 102, is a living individual about whom an investigator conducting research obtains information or biospecimens through intervention or interaction with the individual and uses, studies, or analyzes the information or biospecimens, or obtains, uses, studies, analyzes, or generates identifiable private information or identifiable biospecimens. While this definition is dense, we can further clarify specific terms. A human subject must be a living individual, and thus research about deceased people or their specimens does not meet the definition of human subjects research. The wording "about whom" denotes that the focus of the investigation must be on the opinions, characteristics, or behaviors of the individual. Asking an individual to provide information about something else, like how many microloans were made in a year, is termed an "about what" question and does not meet the federal definition of human subjects. Interventions consist of physical procedures and behavioral interventions where data are gathered or certain aspects of the subject or their environment are manipulated. Interactions, on the other hand, include interpersonal communication between the subject and the researcher, whether it be face-to-face, by mail, or via online surveys. Private information consists of information about behavior that occurs in a context when an individual can reasonably expect no observation is taking place. For example, a conversation between two people on a park bench or at a table in a restaurant can be reasonably assumed to be private, even though it's occurring in a public place. Information that has been provided for specific purposes by an individual with the assumption of privacy, such as school records, further protected by FERPA, and health records, further protected by HIPAA, are also considered private information. Identifiable private information is private information that the researcher can readily identify who the data came from. For example, if the researcher has access to the link between a random subject ID and the subject's name, that data is considered identifiable private information. Lastly, an identifiable biospecimen is a biospecimen from which the researcher can identify who it's associated with. The common rule does suggest that the definitions of identifiable private information and identifiable biospecimens be reevaluated with the onset of new technologies that can re-identify data.
Hello, today we're going to take a quick look at a foundational piece of policy that governs ethical research in the United States, which is the Common Rule. Understanding this policy is crucial for anyone involved in human subjects research. It is officially known as the 1991 Federal Policy for the Protection of Human Subjects. You'll often hear it referred to by its regulatory citation as listed. This policy was formally published by the U.S. Department of Health and Human Services in 1991, setting a nationwide standard. A key influence on the Common Rule's contents was the Belmont Report. This landmark report provided the ethical principles and guidelines for research involving human subjects, principles which are deeply embedded within the Common Rule itself. While it originated in 1991, the Common Rule was revised in 2017, with those updates officially implemented in 2019. This revision aimed to enhance protection for human subjects while reducing regulatory burden. Most importantly, this federal policy governs all research involving human subjects conducted or supported by any federal agency, as well as any institution that signs on to adhere to its principles. In essence, the Common Rule serves as the bedrock for ethical human subjects research across the federal landscape, ensuring that the participants are protected and that their autonomy is respected when they are at their most vulnerable during their research experiments. Building on our understanding of the Common Rule, let's now dive into some of its crucial aspects since its beginning and highlight the significant amendments made in 2017. From its very inception, the Common Rule brought about essential definitions and requirements. Firstly, it clearly defined the roles, operations, and requirements for institutional review boards, or as it's called, the IRBs. These boards are critical in safeguarding the rights and welfare of research participants. Secondly, the policy meticulously outlined and defined the requirements needed for obtaining informed consent from research participants. This ensures that individuals fully understand the nature of the research and voluntarily agree to participate. Now, fast forward to 2017, the Common Rule underwent some pivotal amendments. These changes were driven by three main goals. First, to strengthen protections for human participants. This was paramount, ensuring even greater safeguards for individuals involved in research. Second, to reduce the regulatory burden on IRBs and researchers. The aim was to streamline processes without compromising participant safety. And finally, to amend regulations to account for advancements in technology and research practice. As science evolves, the regulations need to keep pace to remain relevant and effective. These key aspects and amendments demonstrate the Common Rule's foundational role and its adaptability in ensuring ethical and efficient human subjects in research. There are two very important concepts in human subjects research: private information and identifiable biospecimens. These terms are explicitly defined and derive directly from the Common Rule, and understanding them is crucial for ethical research. So, what exactly constitutes private information? The Common Rule defines it in two key ways. Firstly, it includes information about an individual performing a behavior when there's no observation or recording occurring. Think about someone's private thoughts or actions that are not publicly visible. Secondly, it refers to information that is only available to the individual without them making it public. This means data that, while perhaps existing, is not accessible to the general public or even to the researcher without specific access. Now let's add the identifiable aspect. In the concept of research, identifiable private information and biospecimens are those that are directly tied to an individual and can be readily identified by the researcher. This means if the researcher can easily link the data or the biological aspect of the sample back to a specific person, it's considered identifiable. This direct link is what triggers the highest level of protection under the Common Rule. To give you some real-world examples of how private information is protected, we can look at federal laws like FERPA and HIPAA. FERPA, the Family Educational Rights and Privacy Act, protects student educational records, while HIPAA, the Health Insurance Portability and Accountability Act, protects sensitive patient health information. These are excellent examples of how federal law safeguards private and identifiable information, mirroring the principles found within the Common Rule. Understanding these definitions of private information and identifiable biospecimens is fundamental to ensuring the privacy and autonomy of research participants.
Now that we have a solid understanding of the formal definitions of research and human subject, let's apply these concepts to one of the most pressing topics in ethics today: artificial intelligence. The rapid advancement of AI presents novel ethical challenges for human subject research. While these technologies offer incredible benefits, their application in healthcare raises significant concerns, particularly around data privacy, potential bias, and what it means to give informed consent. To explore this, our case study is based on the article, A Research Ethics Framework for the Clinical Translation of Healthcare Machine Learning. This study provides a comprehensive ethical framework for AI research in a clinical setting. It tackles major issues like the black box problem, where algorithms are hard to interpret, ensuring accountability when an AI makes a mistake, and upholding the core principles of privacy and fairness. In essence, it serves as a practical guide for researchers and IRBs trying to navigate this complex ethical terrain. The framework from our case study highlights 4 key ethical challenges where our traditional definitions are put to the test. The first challenge, evolving definition of identifiable private information. The major issue here is that data we think is de-identified can often be re-identified when combined with public information. This ability to unmask individuals challenges our traditional standards of data privacy. Second challenge is private information and respect for persons. Consent forms can often be vague and may not clearly inform participants that their personal data will be used to train an AI model. This raises a critical ethical question. If a person doesn't know the full scope of how their data is used, is their consent truly informed? The third challenge, we have the immense issue of bias and justice. An AI is only as objective as the data it learns from. If the training data contains historical biases, and it sometimes does, the resulting AI can perpetuate or even amplify discrimination against already marginalized groups. And finally, there is a potential gap in oversight between individual and societal harm. IRBs are designed to protect individual research projects from harm, but an AI algorithm can have a much broader societal impact affecting entire communities. This type of large-scale harm can fall outside the traditional focus of an IRB, creating a significant gap in our ethical oversight. So given these daunting challenges, what is the path forward? The paper offers 3 crucial takeaways for how we can manage AI research ethically. First, and this is extremely important, existing research ethics frameworks can be adapted. We don't need to throw out our current system. There's no need to recreate an entirely new oversight body just for healthcare machine learning. Instead, traditional structures like IRBs can and should be adapted to address the unique aspects of AI research, while always upholding those core ethical tenets of respect for persons, beneficence, and justice. Second, the AI chasm is both an ethical and methodological problem. The AI chasm is the term for the difficulty in translating a lab-tested model into actual clinical practice. This gap is ethical because it involves challenges with data across access and patient consent. And it's methodological because the standards of evidence in computer science, which often focus on technical performance with historical data, simply don't meet the rigorous requirements of evidence-based medicine, which demands proof of impact on real patient outcomes. And this leads to the third and final takeaway. Prospective clinical evaluation is crucial. Like any new medical intervention, machine language tools must be tested through prospective clinical studies to justify their use at bedside. Validating a model on past data is not enough to ensure it will be safe and effective in a real-world clinical setting. We need these forward-looking trials to truly understand the model's impact and identify any unintended harms. In summary, the case of AI in human subject research clearly demonstrates the evolving nature of ethical considerations. As technology advances, our definitions of research and human subject must be continually re-evaluated to ensure we are protecting individuals and society. This image on the screen captures our central point perfectly. We see a modern AI resting on the foundation of traditional ethics, but that foundation is cracking under the strain of these new and unique challenges: data privacy, informed consent, algorithmic bias, and gaps in our oversight. Ultimately, we need to build and reinforce robust ethical frameworks specifically designed to handle the unique challenges of AI. This means directly addressing re-identification risk, demanding more specific informed consent, and actively working to mitigate algorithmic bias. And this leads us to some important questions that we pose for discussion. Number 1, how will the definition of identifiable private information evolve with new technologies, and how can researchers proactively ensure ethical compliance with future HIPAA and Common Role revisions? Number 2, as AI platforms collect and analyze personal data, such as behaviors and speech patterns, should the sources of AI data collection be considered as human subjects under the Common Rule guidelines? If so, how the guidelines adjust to protect informed consent and private policies? Number 3, how can researchers ensure the validity and accuracy of these AI-generated data, and what could it mean for potential spread of misinformation to the public? Number 4, do human subjects protections change if the data collected is only used for AI model validation or testing? In these cases, is the use of human data defined as research?